Visit us at Eduvvo. Thank you for calling Eduvvo.
Now, more than ever, you hear about the importance of STEM education and the need for qualified computer programmers. Maybe you even know someone who started learning to code. Or perhaps you've heard about how programming can be a rewarding, lucrative career. Whatever the reason, this course is designed for you. Someone who's curious to pull back the curtains and explore the world of computer programming. I'll walk you through your first line of code, explain the core concepts needed to write useful programs, and take a peek at several programming languages along the way. I'm Anise Davis, and I've worked in the software industry for over a decade, and programming is one of my favorite things to do. I also love to share what I know with others, so I'm really excited to help you master the fundamentals of programming here on LinkedIn Learning. What is programming? Well, when you pick up your phone and check the time, respond to a message, or comment on a friend's picture, you're experiencing the results of what someone programmed your phone to do. Programming is the process of converting ideas into instructions that a computer can understand and execute. These instructions are specific and sequential. You can think of it a bit like a recipe. Let's say you wanted to bake a cake. You would first need a list of ingredients and then the set of instructions. For our ingredients, we have flour, sugar, eggs, milk, and so forth. If you've ever baked a cake, you know that the amount of each ingredient can dramatically affect the outcome. If you accidentally use a full cup of milk instead of a half a cup, then you'd have a runny mess on your hands. Or what if you swapped the baking soda for salt? The cake would never rise. In a similar way, the instructions we provide to computers need to be specific so that we can get our desired result. Computers are very literal. They try to execute our commands exactly. When we give them bad instructions, we might introduce bugs or even make the computer crash. In programming, a bug is when something unexpected happens, whereas a crash is when your program stops early or freezes, just like if you use the wrong ingredients in your cake. Instead of a fluffy, moist cake, you could have a flat, runny disaster. The other characteristic of computer instructions is that they're sequential, just like the steps in a recipe. The order of the steps will impact your final product. If we mix the baking soda in before the eggs, we can cause our cake to be dense. Or adding the milk with the butter may cause the dry ingredients to clump and leave us with a lumpy cake. Order matters. The same thing can be said about programming. It's all about giving computers the right instructions and the correct sequence of steps to produce the desired result. This is important because programming is just as much about finding errors and preventing crashes as it is about writing the instructions or code that the computer understands. So to recap, programming is how we communicate with the digital world. It's characterized by having instructions that are specific and sequential. And when we get our code right, just like in a recipe, the end result is a program that helps us to enjoy a bit more of our world. When you want to provide instructions to a computer, you use what's called a programming language. There are hundreds, if not thousands, of programming languages available, each made up of its own syntax or rules and semantics or meaning. Let me give you an analogy. In English, we would write welcome and use one exclamation mark. But in Spanish, we would write bienvenido. Semantically, they mean the same thing. But Spanish, unlike English, requires an exclamation mark at the beginning and end. This is one rule or syntax of the Spanish language. Likewise, programming languages also have unique syntax rules. Let's look at a few examples of the Hello World program. Maybe you've already heard of it before. It's the most basic program used for decades to get started with a new programming language. It helps to highlight the differences in syntax between languages. First, we'll look at a language called C++. This is how we would get the program to display Hello World when run. Now, it may look strange to you, but that's okay. Soon you'll be able to understand exactly what's happening. For now, I want you to just notice the syntax used in the language. This consists of double quotes around the words Hello World, the use of a semicolon at the end of statements, and there's a return keyword right before a closing curly brace. All of these things are part of the syntax or rules of the C++ programming language. Let's look at a few more examples. This language is called JavaScript. It's a very popular language used in virtually every website these days. This is how we would display Hello World using JavaScript. Notice the use of different syntax. First, the words Hello World are now inside of single quotes. We don't have any curly braces. Instead, we see something about document.write. And finally, here's Hello World in Python. Similar syntax to JavaScript, but now we don't see any parentheses, and the use of double quotes has returned, just like we saw with C++. Now you may be wondering, what's the point of having so many different languages, especially if they do the same thing? Why not just have one programming language and we all use it? The main reason why we have so many languages is that each comes with its own set of strengths and weaknesses. Some are ideal for programming small devices with limited memory, whereas others were made to handle complex mathematical computations. Regardless of the language you choose, ultimately, that language has to be broken down into the only one that computers understand, machine language. Machine language is extremely complex for us to write directly because it's mostly just a series of numbers. Professor Mike Dehan compared machine code to DNA molecules. Can you imagine trying to read a DNA sequence atom by atom? That would take you forever. And this is why we have these other languages that we call high-level languages. They're closer to human languages, comprised of keywords, structure, and syntax that's easier for us to learn and understand. Writing source code is what programmers do all day. It's the instructions we have for the computer, and it's written in plain text. In other words, we write it without special formatting like bold, italic, or different font types. It's mostly just the actual characters. This means that word processing applications aren't suitable for writing code, because by default, they insert bits of information in files that prevent them from being plain text. Instead, you can use a text editor. If you're on a PC, you already have a text editor available to you, Notepad. And for Mac users, there's TextEdit. Both applications allow you to write source code. Let's look at an example. I'll be using TextEdit since I'm on a Mac. We're going to go ahead and open up TextEdit. And the first thing that you'll notice is this formatting bar. By default, TextEdit stores files in rich text format. That means you can do things like bold or italics, or even underline. But this is not suitable for writing source code. To change it, we're going to go over to TextEdit, choose Preferences, and then we're going to choose Plain Text under the Format section. Also, make sure you uncheck all of the options down below. Great. We can close our Preferences pane, and let's restart TextEdit to make sure that our changes are still present. Perfect. Now that formatting bar is no longer here. If you're on a PC and you're using Notepad, you don't have to worry about this. It uses plain text by default. So let's start off by doing our favorite program, Hello World. We're going to do the Python version. Let me zoom in a bit so you can see what I'm doing. I'm going to type print, open parentheses, double quotes, hello world, exclamation mark, double quotes, and a closing parentheses. We did it. We've written some source code. Source code can either be one line like you see here or thousands. It just depends on the needs of your program. Let's go ahead and save this file. By default, TextEdit saves files with the .txt extension. This is because it's plain text. But it's best practice to use an extension that corresponds to the programming language that's inside of your file. Since this code was written in Python, we're going to use the Python extension, which is .py. So let's save this as 01_03.py. Perfect. Each programming language has its own file extensions. For JavaScript, it's .js, Perl, .pl, whereas a language like Kotlin uses .kt. Now that we know how to write our code, we need to learn how to translate it into the language that the computer speaks, machine language. This is a vital step to get it running on any device. If we were to double-click our Python file, it would just open in an editor, but it wouldn't do anything with the code that we put inside. Why is that? Well, it's because Python is an interpreted language. This means we have to interpret it into machine code, and we haven't run the interpreter yet. There are three main ways to translate source code into machine code: compile it, interpret it, or a combination of both. Compile, interpret. Let me give you a real-world example. Say you need to write a letter to someone who speaks Mandarin but doesn't speak English. What would you do? You could first write it in English, then use a translation service to convert your letter into Mandarin and mail it. The other person would never see your original letter, only the one that was in Mandarin. That's basically what compilers do. They take your high-level programming language and turn it into an executable that contains low-level machine code. This way, users can run your code on their machine without ever needing your original source code. Now, the second option for sending out a letter is to send it to them in English. Then they could have a friend who speaks English read each line of the letter first and tell them what it means in Mandarin. Every time our Chinese friend needs to read the letter, the interpreter will need to come back over and reinterpret the letter. This is essentially what computer interpreters do. They process your source code each time it's run, line by line, and it's up to the other user to have the needed interpreter available on their machine. Now, this is of course an oversimplification of both compilers and interpreters. They perform complex functions that help to optimize the size, speed, and security of your source code, but it helps to convey the general idea of how they differ. Typically, languages like C, C++, and Objective-C are known as compiled languages, whereas PHP and JavaScript are known as interpreted languages. And finally, Java, C#, and Python use the combination approach. Nowadays, the line between compiling and interpreting is a bit blurry, as many languages have some variants of both. The key thing to keep in mind is that you may need to perform additional steps to get your code to run on your or someone else's machine. You can write entire programs in simple text editors, but in practice, few programmers do. They use enhanced text editors called Integrated Development Environments, or IDEs. IDEs provide features that speed up code development. When you want to write a letter, an essay, or a resume, what tool would you use? You'd probably use a word processor, such as Microsoft Word or Google Docs. They have special tools that help you check grammar, spelling, and add nice formatting. For programming, we use an IDE in the same way. An IDE is an application that provides the special tools needed to write, debug, and compile code. Let's take a look at two popular IDEs to see what they have to offer. Don't worry about downloading anything right now. We're just going to check them out together. We'll start with Xcode. Xcode is used to develop applications for Apple products, like the iPhone, iPad, or Mac. Right away, you can see a difference between our simple text editor and a more sophisticated IDE. We have line numbers on the left side of our source code editor. This allows us to more quickly reference individual statements in our code. There's also the use of color, known as syntax highlighting, to aid in pointing out important keywords and improve the readability of our code. And finally, Notice how you can even preview what your code will look like when compiled and run on a real device. Definitely a great tool to improve your coding process. Now, although Xcode is really nice, let's look at one more example. Visual Studio Code. Visual Studio Code, or VS Code for short, is a more lightweight editor than Xcode, and it was initially designed for scripting languages, such as JavaScript and TypeScript. However, it gradually came to support many more languages through powerful extensions. You'll find developers using it to develop apps in dozens of languages. One of its unique features is called IntelliSense. This allows you to get code suggestions while you're typing. It works a lot like autocomplete when you're sending a text or when you search in Google and it guesses the rest of the phrase you're typing. And unlike a simple text editor, we can actually run our Python code from within the IDE. It's really cool. And there are many more IDEs out there. My favorite is Android Studio, as I spend lots of time creating Android applications. But when I'm working on an application written in Ruby, I turn to RubyMine, as it's tailored for the Ruby language. Programmers love to talk about which IDE is their favorite. If you have an hour or two to spare, just ask any programmer what IDE they think is best. Then get ready to pull up a chair. IDEs can ease the burden of software development by providing tools to help you write, debug, and run your source code more easily. Ultimately, it's up to you to find one that meets your needs, and you don't mind using it for hours a day. When choosing the language for this course, I had two main requirements. It needed to be popular and easy to learn. As far as being popular, right now the top 5 programming languages are Java, Python, JavaScript, C++, and C#. That narrowed down the list considerably. But when it comes to ease of learning, both Python and JavaScript have fewer syntax requirements than the other languages. So let's look at those two. Both Python and JavaScript tend to be more concise. This means it takes fewer lines of code to get things done. They're also easier to understand, as both languages use structure and wording that are closer to human language. But which one to choose? Well, JavaScript was designed to work with and manipulate web pages, and it continues to be widely used for that very reason, although it can also be used for non-web applications. Python, on the other hand, was designed to be a general-purpose language. You can use Python to create web apps, internal company tools, perform scientific analysis, as well as create games. The Python language has been around for decades, and it's available on multiple platforms, including Mac, Windows, Linux, and more. It's a great choice for exploring the various concepts that we're going to cover. So for this course, Python is the winner. We've already seen some Python code. Remember our simple Hello World program? That was written in Python. This is also Python code. Can you guess what it does? If not, that's okay. By the end of this course, not only will you know what it does, but you'll be able to write similar programs yourself. If you're using a Mac computer, getting Python set up is very easy. The Mac operating system ships with a version of Python already installed. If you're using Windows, please skip to the next video, as I'll walk you through how to get set up. To check what version of Python is installed, we're going to open a terminal window. Terminal is an application that lets you run commands to explore directories, execute scripts, and yes, work with Python. To open up Terminal, we're going to go to our Finder, then Applications, go to Utilities, and open up Terminal. You can also do this with a shortcut by typing Command Space and then spelling out Terminal and hitting Enter. Let's go ahead and close down our Finder window. From here, we can check what version of Python we have installed. To do that, we're going to type Python, all in lowercase letters, and then hit Enter. Let me go ahead and zoom in a bit so you can see what I'm doing. The first thing you notice is that it prints out the version of Python that we're running on the machine. Now, typically when we say print out in programming, we don't mean go grab a piece of paper from the printer. Instead, it's referring to displaying the result of a command on your screen. Programming languages have version numbers associated with them because over time new features are added. By increasing the version number, the developers of the language are communicating that they've changed something, and it could impact how you use the language. At the time of this recording, we have Python 2.7.10 installed. Notice how we're inside of the Python prompt. This is denoted by the 3 angle brackets. This is letting us know that the computer is ready for us to send it some Python instructions. But for now, we're just going to go ahead and exit. We can do this by typing exit and then an open and close parentheses and hitting enter. If for some reason you don't see the version of Python that's installed, or you're not sure if you're running the latest version of Python, you can head over to python.org/downloads. Let's do that now. Here, you can see the latest version of Python that's available for your operating system. In this case, Python 3.7.3 is the latest version. And since this is newer than what we have installed on our Mac, let's go ahead and download it. Once it's finished downloading, you can go ahead and double-click the file to open it up. This will show you the Python installer. Let's click on Continue to walk our way through the wizard. Now you may have to enter your password to let your computer know that you're okay installing Python. And that's it. We have Python installed. Let's go ahead and close all of these windows. Now that we have it downloaded, we no longer need this window. So we'll close it and we're back here inside of our terminal. Just to make sure we have the latest version available, we're going to restart. So let's quit. We'll use that shortcut, Command Spacebar, and then Terminal. And now, let's type the Python 3 command, no spaces between. Great! And just like that, we're running the latest version of Python. If for some reason you're not able to get Python installed, I've added a troubleshooting guide for you. But otherwise, you should be running the latest and greatest version of Python. To install Python on your Windows machine, you need to go to python.org. Let's do that now. From here, go to the Downloads tab, and then we're going to choose Download Python 3.7.3. Programming languages have version numbers associated with them because over time new features are added. By increasing the version number, the developers of the language are communicating that they've changed something, and it could impact how you use the language. Now that that's downloaded, we can click on the executable in order to launch the installation process. Make sure you choose the Add Python 3.7 to Path checkbox option. Then you want to click on Install Now. Okay, now that the setup was successful, let's close this as well as the browser window. To open our newly installed Python installation, we're going to come to the Start menu, and then we're going to navigate down to where you see Python. If we expand this folder, there's multiple executables present, but we're going to use the one that's Python 3.7. When we click this, this will open up the Python prompt. It's at this point that we can start sending some instructions to the computer. For now, we're just going to exit. And we'll do that by typing exit with an opening and closing parentheses. And that's it. If for some reason you're not able to get Python installed, I've included a troubleshooting guide for you. But otherwise, you should be running the latest and greatest version of Python. One way to execute or run your Python code is by using the command line. Let's open up Terminal and try out a few commands. Let's go ahead and launch the Python interpreter. We'll use the Python 3 command. Now we're inside of our Python prompt. This means the computer's ready to take our instructions. Let's try out a simple math problem. 2 plus 2. First, we'll try it with, what is 2 plus 2? Uh-oh, we get a syntax error. Recall that syntax refers to the rules of a programming language. Syntax errors happen when you write code that breaks the expected rules. In this case, we wrote our code in plain English, but the interpreter doesn't understand English, only Python. Let's try this again. This time we'll type 2 plus 2. And just like that, we get 4. That's because 2 plus 2 is a valid Python expression. Let's try another one. 2 plus, and then enter. Once again, another syntax error. That's because this is not a complete Python expression. For example, in English, I could say, "You're doing a great job with the course so far." That's a grammatically correct sentence. But if I were to say, "You're doing a great job with," that would be an incomplete sentence. I didn't finish it up. Programming languages work much the same way. They need you to follow the syntax or rules in order to understand your commands. Let me show you one more thing. First, we're going to exit our Python prompt. We'll do that by typing exit, or we could also use the shortcut Control-D. So now we're outside of the Python prompt. Do you remember our 0103 file? Let me show you how we can run it from the command line. The first thing we need to do is make sure we're in the same directory as our file. To do that, we'll use the cd or change directory command, and we'll go to our file, which is located inside of desktop/exercise files/chapter01. Now, if we hit enter, let's go ahead and make sure we're in the proper directory. We'll do that using the ls, or short for list command, which is available on Mac and Linux. And there you have it. We see our Python file. To run it, we're going to use the Python 3 command with a space and then the name of our file, 0103.py. Great, we were able to get the output of our file here on the command line. Most of the time, you'll run your code directly in the IDE, though you may have occasions where you want to run some Python code from the command line. And now you know how. One way to execute or run your Python code is by using the command line. I'll be referring to it as the terminal or command line throughout this course. You can access it on your Windows machine by going to the Start menu and then navigating to the Python folder. When you get to the drop-down, choose Python 64-bit. This is going to open up the Python shell. The Python shell will display the prompt, which lets us know that the interpreter is ready for our Python instructions. Unlike the Mac, you don't need to type anything else to start sending Python commands. We'll start out by trying to get the sum of 2 plus 2. Let's see what happens when we type, "What is 2 plus 2?" and hit enter. Well, we get a syntax error from the Python interpreter. Recall that syntax refers to the rules of a programming language. Syntax errors happen when you write code that breaks the expected rules. In this case, we wrote our code in plain English, but the interpreter doesn't understand English, only Python. Now let's try that again, but this time we'll type 2 space plus 2 and then hit enter. And look, we get back the number 4. That's because the expression 2 plus 2 is valid in the Python programming language. But what if we were to just type 2 plus and then hit enter? Well, we get another syntax error because our expression was not complete. For example, in English, I could say, "You're doing a great job with the course so far." That's a grammatically correct sentence. But if I were to say, "You're doing a great job with," that would be an incomplete sentence. I didn't finish it up. Programming languages work much the same way. They need you to follow the syntax or rules in order to understand your commands. For now, let's exit the Python prompt. We can do this by typing exit, open parentheses, close parentheses, and then hitting enter. Remember our 0103 Py file? Let's see if we can run the code contained in it. First, we'll need to open up the command prompt. To do that, we'll come down to search, and we'll type command, and we'll choose prompt. Next, we need to make sure we're in the same directory as our file. My file is located on my desktop inside of the exercise files folder. Yours might be in your downloads or another location. The first thing we're going to do is to type cd or the change directory command, and then we need to find the path of our file. I'm going to open up the File Explorer, and then I'll navigate to where my file is located. First, I said it's on the desktop. I'll choose the Programming Foundations folder, then Exercise Files, and I want the file that's inside of Chapter 01. So I'm going to drag this folder over to my command prompt. Now when we close down the File Explorer, notice that the entire file path has been copied for us. It's pretty sweet. Next, we're going to type enter. We're now inside of the Chapter 01 folder. I'll then type the dir command, which stands for directory, to get a list of all the files that are contained in this directory. And I see my 01_03 Py file. In order to execute it, I'm going to type python 01_03.py and then hit enter, and we get our hello world. Throughout this course, I'll be using a Mac computer, so I'll often refer to Python 3 instead. But for Windows users, typing strictly Python will work just fine. Although most of the programs that you write in your IDE you can run directly from there, you may have occasions where you want to run some Python code from the command line. And now you know how. We'll be using Visual Studio Code, or VS Code for short, as our IDE for this course. VS Code is a great cross-platform editor, as it's fast, easy to customize, and has a friendly user interface. To get started, we'll open up the VS Code webpage. I'll be showing you the setup for the Mac operating system in this video. If you're using a Windows machine, please skip to the next video. So the first thing we're going to do is come to code.visualstudio.com, and then we're going to choose the Download for Mac button. Once it's finished downloading, we can double-click the zip file to open it up. And in order to use Visual Studio Code, we're going to copy our file over to the Applications folder. Now we can go ahead and open up Visual Studio Code. Let's close down the browser. The first thing you'll see when you come to Visual Studio Code is the welcome screen. From here, you can create a new file, open up a folder, or customize it with extensions. In order to understand a bit more about this particular IDE, we're going to go to the Learn section and click on the Interface Overview. From here, we can see the various options that are available to us inside of VS Code. First, we can explore the various files, search across files, or we can even use things like source code management. Further, we can do launching and debugging, as well as manage extensions. For now, this is good enough to get you started. So we're going to hit exit to leave this overview. Great. In order to work with Python inside of Visual Studio Code, we need to use a Python extension. So the first thing we're going to do is go to Tools and Languages. And then we're going to choose Python. It's the very first option. If we click on this extension, we get tons of information about the various features that it supports. It has things like linting, debugging, or code navigation. Don't worry if you don't understand everything about this right now. It'll become more and more familiar as you continue on your programming journey. For now, let's go ahead and install it by clicking on the Install button. And then once that's complete, we can go ahead and restart Visual Studio Code. So we're going to quit and then open it up again. Now, before we can officially get started working with Python, we need to choose an interpreter. Remember, Python is an interpreted language. That means it goes through your code line by line in order to give you some results. To install an interpreter, we can open up the command palette. You can access the command palette using Command-Shift-P. And then you want to choose Python, select Interpreter. From here, you have various options available to you. We want to choose the Python 3 option, as this is the very latest version that we've already installed. So I'll just choose the very last one. And that's it. We now have everything we need in order to write and run our code inside of an IDE. To get started, we'll open up the VS Code webpage. Once you're here, you want to choose Download for Windows. Once it's downloaded, let's click on the executable in order to launch the installation flow. Now that we've launched the installation flow, let me go ahead and close this browser window, and then we'll walk through the flow. First, we're going to click on Next and make sure you accept the agreement. We'll click Next again, choose the default location for installation. We'll keep everything the same for the defaults. And when it comes to selecting the additional task, I recommend you choose every option, as this will make it easier for you to work with the exercise files. Let's click Next again, and then finally install. Okay, now it's finished. Let's go ahead and launch Visual Studio Code. Now that the app is launched, we're greeted with the welcome screen. From here, we can create a new file, open a folder, or add a workspace folder. For now, let's take a quick look at some of the features of this IDE. We can do that by coming to the Learn pane and choosing Interface Overview. The key things that you'll want to work with for this course are the File Explorer, where you can see all of the files listed, searching across files in case you need to find one with a specific name, managing extensions, which we're going to talk about shortly, and then also finding and running all commands. Let's escape it by just clicking on the overlay. The next thing we want to do to get this ready to work with Python is to go to the Customize pane and choose Tools and Languages. This is going to open up the extension pane on the left side, and one of the options is Python. If we click on the Python extension, we're going to get lots of details about how Python works in Visual Studio Code. What's nice about VS Code is that for each extension, you have a detail screen, which tells you about the different features that are included. For instance, in the Python extension, we get linting, debugging, code formatting, and much more. But you don't have to worry about all of that for this course. We're only going to use very limited features. So make sure that you install the extension if it's not already available. Remember, Python is an interpreted language, meaning it processes your source code each time it's run, line by line. So in order to run Python code and get code suggestions, you must tell VS Code which interpreter to use. Let's do that now. We're going to close down the extension, and then we're going to open up the command palette. To do that, we're going to type Control-Shift-P, and then start typing Python, select interpreter, and choose it from the dropdown. It's going to give us the option for Python 3.7.3, which is the one that we had installed previously. So now we can just select it, and we're ready to go. That's it. We are ready to start writing and running our code in an IDE. Let's take a look at a few ways we can run our Python programs in VS Code. Let's go ahead and open up our exercise files folder. To do that, we're going to click on Open Folder, and then we're going to choose Exercise Files. Now, the first thing you'll notice over here on the Explorer pane is that we have a list of all of the folders inside of our exercise files directory. But there's this one folder that we didn't create, .vscode. You don't have to worry about changing anything here for the course. This is just a special folder created by VS Code in order to store some metadata. Let's go ahead and open up one of the files. We're going to open the one inside of chapter 02, and we're going to choose 02_07. This looks really different from what we've seen before in our simple text editor. The first thing you notice is the use of line numbers over here on the left side. We call this the gutter. Using line numbers inside of IDEs makes it easier for us to find code later on. For example, on line number 3, we have the print statement, goodbye world. What's another thing you notice that's really different? It's the use of color. We call this syntax highlighting. This is how we can point out special keywords or various objects inside of our programs. For example, the print keyword is yellow, whereas the hello world is orange. But how did VS Code know to choose the colors for the Python programming language? Well, it's based on the fact that we're using the .py file extension. This is the file extension used for Python code. Now let's say we want to run this code. We can click anywhere inside of our file, right-click, and go to Run Python File in Terminal. Let's do that now. Notice that we see our output. Hello world, goodbye world. We've done this using our IDE. Now, what if we weren't interested in running all of the code in a file? Well, we could even use just one portion. For example, let's run line number 3 only. We'll come to this line, right-click, and we'll choose Run Selection or Line in Python Terminal. And now we only get goodbye world. What's really nice is that this actually launches a real Python shell for us. So if we want, we could even run other Python commands. For example, 4*4. This is how we do multiplication in Python. When we hit enter, we get 16. Now let's go ahead and exit this, the same way we would our normal terminal from the command line. We're going to type exit. And we're no longer inside of our Python prompt. And to leave this entire area, we can just click the close button that's in the right corner. Great. And that's it. We've seen a few different ways that we can run our Python programs inside of VS Code. And it's nice that we have such helpful features like the line numbers or the syntax highlighting. I encourage you to explore running some simple commands on your own so that you can get the hang of it. You could have all of the ingredients to bake a cake, but if you don't have a recipe, then there's no cake. It's the same way with statements. Statements are the building blocks of any program and are the individual actions that you want your program to take. Without statements, there's no program. Each statement can be made up of keywords, expressions, and operators. We'll talk more about keywords later. For now, we'll focus on expressions and operators. Operators are symbols that tell the computer to perform an action with some input. And the good news is, you're already familiar with many of the operators that are used in programming from your primary school education. In this table, you can see a partial listing of some operators that should be familiar to you. The plus symbol used for addition, minus for subtraction, an asterisk or star to represent multiplication, and finally a / for division. These are known as arithmetic operators, as they take numbers for their input and perform an arithmetic operation. Flashback to primary school. When we have 3 plus 2, the plus sign is the operator, and 3 and 2 are the input, also known as operands. In programming, the combination of operators and operands that break down to a single value are called expressions. Let's look at a few examples. If we take the following, 10 plus 2, What does that equal? 12. Correct. 10 plus 2 is our expression, and the 12 is what our expression evaluated to or equaled. Let's try another one. 10 divided by 2 plus 3. What does this expression evaluate to? Yes, it's 8. Now let's look at another expression where the answer may surprise you. 2 plus 3 times 6. What do you think this expression evaluates to? It's 20. Now, if you thought 30, that's understandable. But in programming, the default order of operations is the same as in mathematics. The plus or addition operator in our example is evaluated after the asterisk or multiplication operator. That's why we get 20 instead of 30. If you're from the United States like me, you may have been taught the phrase, "Please excuse my dear Aunt Sally," as a way of remembering the order of operations, or PEMDAS. That stands for P, parentheses first, E, exponents, MD, multiplication and division, from left to right, and finally AS, addition and subtraction, left to right. It's important to keep the order of operations in mind, as your program could behave unexpectedly based on how an expression is evaluated. If we go back to our last expression, it evaluated to 20 because of the order of operations. But what if we, as the programmer, wanted it to process the addition first? In that case, we would add in the parentheses around our addition operation, and then we would get the result that we wanted, 30. Computer programs are made up of statements. Statements that can perform a mathematical calculation, display something to the screen, or even make a choice between two code paths. As we continue to explore the fundamentals of programming, you'll see just how powerful this concept really is. One of my favorite quotes about programming is from Alan Perlis, who said, "There are 2 ways to write error-free programs. Only the third one works." This play on words is meant to highlight the fact that programs tend to have bugs, and you're not doomed as a programmer if you run into issues when writing and running your code. But when you're first getting started, what can you do to figure out why your code is acting up? Well, first, you need to understand what type of bug or error you're dealing with. Errors tend to fall into 3 categories. Syntax. You somehow broke the rules of the language. Runtime. The computer was unable to execute a portion of your code. And finally, semantic. The output of the program is not what you expected. Let's look at an example of each type of error. We'll go to the command line and start our Python shell. We'll start out by typing print and then hello world. And finally, enter. Uh-oh, we didn't get our familiar hello world like we expected. This is because the quotes were missing. The Python interpreter didn't understand what we wanted it to do. When you come across these types of errors, it's best to slowly review each line of code to see where you have missed providing a set of quotes, parentheses, or a colon. The next type of error is a runtime error. This happens when your program is actually running. Let's look at an example. We're going to create a new statement. This is going to use the expression 10 times 2 divided by 0. Now let's hit enter. And we receive a 0 division error. But why? This is because division by 0 was attempted. From mathematics, we know that division by 0 is undefined. The Python interpreter has no idea what to do with that expression, so it just fails. When you come across runtime errors that you don't understand, the best thing to do is look it up. My preferred website for doing so is stackoverflow.com. You can copy and paste the error message and then look for similar questions to what you're experiencing. When you click on the question, you'll often find a suitable answer. Now, the final type of error is a semantic one. This is when the output of the program is not what you expected. Let's take a look at an example. We're going to print out Hello Alice. We'll start by creating a variable called name, and we'll set it equal to Alice, and hit enter. Next, we're going to use our print statement, and we're going to include hello, and then name, and enter. Oh no, look what happened. We have hello name instead of hello Alice. That's because we didn't use the proper variation of the print method. Python didn't understand that we wanted it to use the name variable. Semantic errors are the most challenging to troubleshoot. It's best to make tiny changes and then run your code. That makes it easier to figure out where you introduced the error. Also, I find going for a short walk helps me to clear my head and come back to the problem with fresh ideas. Ultimately, you need to have a good sense of humor. Sometimes these issues pop up from the smallest of mistakes. Just laugh it off and keep moving forward. It's all part of the process. Writing code typically involves the handling of information. If we're making a game, we need to store the user's score. If we're creating a banking application, we'll need to have their current balance, and so forth. We've already seen a few variables in the course so far, but now we're going to go into more detail about what they are and how they work. A variable is simply a container for a value. When we run our programs, the computer gives us space in its memory where we can put data that we want to use as a reference for later. This data is called a variable. Much like how we label jars in our kitchen so we know where to go for our favorite cookies. We declare variables in Python by giving them a name and then setting their value. This is called assigning the value. And this assignment is done with the assignment operator, which is the equal sign. As we see here, age is the name of our variable. And because of the equal sign, we are assigning it the value of 36. That means that somewhere in the computer's memory, it's made space for our variable and stored our value in it. Later, when we ask the computer to print what's inside the age variable, it prints out 36, the value that we assigned previously. Although we're using an equal sign, try not to think of it the same way you did in high school algebra. In programming, the equal sign means I want to take the value on the right and store it in the variable on the left. It doesn't mean the two sides are equal. That's important to keep in mind. Okay. Let's look at another example. This time, we've created a variable named email address, and we've assigned it to the following value, john.doe@example.com. If we run this program, we can see that the values of our variables are printed out. Now, even though we've created both of these variables by giving them a name, there's something different about the value that we assigned them. Can you spot the difference? Yes. It's that with the first value, we are only using numbers. And for the second value, we have double quotes with letters and symbols inside. This is because we want the variables to represent different data types. A data type allows us to put our variable in a particular category so that the computer knows how much space to give us in its memory. And it generally knows how we plan to use our variable later on in the program. In this example, the 36 is an integer, like what we're already familiar with from math class. In case you've forgotten, an integer is a whole number, no decimal places. And the letters and symbols inside of the double quotes is called a string, because it's made up of a string of characters. In fact, you can check the type of any value or variable in Python by using the type function. Let's take a look. We'll print out the type of the age and then the email address variables. And look, the age is an int, or short for integer, and the email address is str, short for string. There are many other types of values available in Python as well. We'll get a chance to explore more of them soon. Depending on the programming language that you're working with, variables can behave in different ways. Some languages require that you define your variables and their types before you can use them, like Java, C#, and C++. For example, if we want to store the name of a cookie in Java, we would have to first declare that it's going to be of type string, and then give our variable a name, cookie. When we run this code, we get sugar as our output. Since we've defined our variable as type string, we can't then later decide to set this variable to a different type, let's say an integer. When we compile our program, we'll receive an error because Java is a strict programming language. It doesn't allow you to reassign data types in this way. But if we were to compare this to a more relaxed language like Python, we don't need to declare a variable's type before using it. Here, we declare the variable and use it at the same time. Notice how we only provide the name, not the type. But when we run this code, the Python interpreter was able to figure out the type based on the value that we provided. What's more, if we wanted to provide a value of a different type, Python has no issues with that either. It just figures it out and keeps on moving. There are pros and cons to both styles. The more relaxed languages tend to be more flexible and result in less code. Whereas with more strict languages, you have fewer surprises when the code is actually run. If you created an account balance variable as an integer, you don't have to worry about it later being set to fill, for example. Like all things in programming, there are a few rules that we have to follow when working with variables in Python. First, variable names should contain only letters, numbers, and underscores. And even though numbers are allowed, the name shouldn't start with a number. 3 blind mice would not be a valid name, for instance. Second, spaces are not allowed in the name. Account space balance would be invalid, but account underscore balance would be just fine. Third, it's important to know that names are case sensitive. Capital C cookies is not the same as lowercase c cookies. Python considers them to be 2 different locations in memory. And finally, variables cannot be keywords. These are reserved words that mean something special to the Python interpreter, like and, break, or try. We'll learn more about keywords shortly. However, if you're ever curious about the complete listing of keywords in the Python language, you can run the following code snippet to get a listing of all of the keywords. In general, you want to use short, descriptive names that make your code easy to understand. Naming things takes practice. In fact, it's often cited as one of the hardest problems in computer science. Keep that in mind and be patient with yourself as you get used to working with variables. Programming is all about numbers. And before you start to have flashbacks to high school algebra, I'm not talking about complex mathematical calculations. We use numbers to store a person's high score in a game, to represent the current amount of money in someone's bank account, or even the number of likes on a picture. Python treats numbers in a few different ways depending on how they're being used. And the difference is largely based on whether it's a whole or a fractional one. Let's look at a few examples. We can use the command line for this as we just want to do some basic math. So let's go to the command line and start our Python prompt. Remember, we can do that using the Python 3 command. We'll start out easy. 2 plus 3. That gives us back 5. No surprises there. Let's try another one. 2 asterisk and then 3. When we hit enter, we get 6. An asterisk or star is used for multiplication in Python. Let's go to another one. We'll use the 2, a double asterisk, and then a 3. This is used for exponents. It's exactly the same as 2 times 2 times 2. Let's try another one. 3 with a forward slash and then 2. This is how we do division inside of Python. Now, what if we didn't want to have a remainder as a result of our division? Then we could take advantage of a separate operator called the floor division operator. Let's see that one now. We'll use a 3 with a space and 2 forward slashes, and then our 2. This time we only get 1 as a result. And the converse is also available to you. If you only wanted the remainder, we could use the modulo operator. For that one, we're going to do 5, the percent sign, and then the number 3. This is going to give us 2 because 3 only goes into 5 one time and has a remainder of 2. And finally, what if we have a really large whole number, like 45,000? How does Python handle that? Let's take a look. We'll type 45,000 and then we're going to divide it by 5. Not what we were expecting. That's because the use of the comma really confused the Python interpreter. So no matter how large the number is, we use no commas when we're working with Python. So let's try that again. This time we're going to remove the use of the comma. 45,000 divided by 5. And there you have it. We get the answer that we were looking for. Now, here's a table of the most common operators that you'll work with. So far, we've only been using whole numbers or integers to do our calculations. But in the real world, fractional numbers are a daily part of our lives. For instance, if you make $24.75 per hour, would you be okay if we just dropped the 75 cents and only paid you $24? Of course not. That extra 75 cents has value to you. In some programming languages like JavaScript, there's only one type for all variations of numeric values. There's no distinction between numbers with and without decimal places. Whereas in most programming languages, numbers with decimal places are considered special, and they're typically called floats. A float is any number with a decimal point. It's short for a floating point number. It's used for when more precision is required, like in the case of our hourly rate. Let's look at how Python works with floats. First, we're going to try 0.2 plus 0.3. And when we hit enter, we get 0.5. We use 2 floats and we get back a float in our answer. Let's try another one. 0.2 divided by 0.3. Whoa, it's a huge number. That's because Python tries to be as precise as possible. You may notice lots of extra decimal places when working with floats. Just ignore them for now. Later, we'll learn how to tweak it to our own liking. Let's talk about strings. In programming, whenever we have to deal with text, be an email address, someone's name, or even an emoji, we use strings. The name comes from the fact that it's a string of characters one after the other. The characters can be letters, numbers, symbols, and even spaces. They're typically represented by beginning and ending quotes. Strings can be passed directly to functions, or they can be stored in variables. For example, we can use the print function in Python to display a message on the screen, like, "Hi there." Notice that we have the opening and closing double quotes. These let Python know it should print out the characters in between the quotes, just as we've typed them. We could also define a variable which contains the same string, and we'd get the same result. In fact, with Python, we could use single quotes to create a string as well. But you might be wondering, why would I want to use the double quotes version over the single quotes version of strings? Well, it depends on the contents of your string. Let's see what happens when we print out the following string that's wrapped in double quotes. She said, double quote, unbelievable, double quote, to him. We receive a syntax error because we've confused Python with our nested double quotes. Instead, we will want to use single quotes to open and close our string. This way, Python knows just what we mean. And the inverse is also true. If we want to use single quotes or an apostrophe inside of our string, like, let's get started, then we would use double quotes at the beginning and end. But keep in mind, you don't want to mix single and double quotes together. Something like this print statement, where we have an opening double quote and a closing single quote, will also lead to a syntax error. When you're first starting out with programming, I recommend using the double quotes version of strings as your go-to. For this course, I'll be using double quotes for strings, as it's the most common version that you'll see across languages. Now that you've got a handle on strings, let's put them to work in our programs. Python doesn't care about extra empty lines in your programs, just like most languages. In fact, it's common for developers to add extra empty lines, also known as white space, to their code in order to make it easier to read. You can think of it kind of like paragraphs in a book. Let's take a look at the 0305 begin file. You'll notice that it's pretty hard to read. Things are really squished together, and we even have a new function thrown in. You might find it especially challenging to figure out what this code is going to do, and that's totally understandable. Let's add a few blank lines so that it can be easier to read. We'll put a little bit of space here, some here after line number 5. Much easier to read. Although in movies, programmers are often depicted as just endlessly typing on the keyboard, we actually spend much more time reading and understanding code than we do writing it. It's important that we structure our code to make that as painless as possible. That's why we add white space. Let's go ahead and add some more white space between the different elements of our statements. So right here on line number 2, we're going to add some white space after name and right after this equal sign. We'll do the same thing again here on line number 5. Just adding more white space. It makes it easier to read. If we save this file and run the code, let's see what it does. Remember, you can right-click anywhere in the file and choose Run Python File in Terminal. It says, "Hi, what's your name?" Let's give it a name. And then when we hit enter, it says, "It's nice to meet you, Jill. Are you enjoying the course?" If we type yes, then it says, "That's good to hear." Hopefully you were able to pick up on what the input function does. It takes some input from the user and then it stores it in a variable. Just like you see here on line number 2. We get some input and then we store it in the variable name. We do the same thing here on line number 5, where we ask the user if they were enjoying the course. Then we store it in our variable, answer. You'll be seeing it again and again, so now you know what it does. Now let's add a bit more space. This time we're going to add space here on line number 7 after our answer variable. And once again after this equal sign. Let's go ahead and save it and make sure we get the same output. So we'll save our file, right-click anywhere, and choose Run Python File in Terminal. Once again, we can enter a name, hit enter, and enter yes for if we're enjoying the course. Okay, great. So we get the same output. Python just ignores this extra white space. However, there are certain circumstances where white space really matters to Python, and that's when it relates to its special keywords. If you recall, there are over 30 keywords that mean something special to the Python interpreter. Let's take a look here on line number 7. If is one of those keywords. If we delete the space between if and the answer variable, let's click Save and run this code. So we'll right-click once again and choose Run Python File in Terminal. Notice that we get a syntax error. That's because Python expects us to have a space after the if keyword. So let's go back and add a space once again after if. Don't worry if you don't understand all the ins and outs of the current code. Just keep in mind that most of the time, Python is very laid back about white space. In fact, you're encouraged to add it in wherever it helps to improve readability. But there are circumstances where Python takes white space very seriously, and your code will fail if you don't respect the rules. The good thing is that the more you practice, the more you follow the rules without even thinking. Comments are notes to your future self and others to describe what your code does. Right now, we have small programs. We can keep the flow of it all in our heads. But over time, as you continue to grow your programming skills, you'll be writing much longer programs. Some may even be thousands of lines of code spread over dozens of files. It will be impossible to keep all of that in your head. By adding comments to your code, you can document the purpose of the different variables, functions, and classes. You can think of them as virtual sticky notes. Here we are with our program that asks the user for their name and also asks if they're enjoying the course. Comments are started with hash marks. Let's add our very first comment here on line number 1. We'll type the hash mark and then a space and type greet the user. Notice how the entire line is now colored green. This is how the IDE is letting us know that this line is a comment. We can go ahead and save it. Now, there's another way that you can include comments in your code. You can also add them to the same line as existing code. Let's come down here to line number 4, and right after we have our input function, we'll add a space and another hash mark, and we'll type ask the user their name. And just like that, we have another comment. So when Python sees this hash mark, it knows that it can ignore the rest of the line. Let's save this and see if it has any impact on our output. We'll right-click in the file and go to Run Python File in Terminal. Just like before, we get our greeting and it asks us, what's our name? After hitting Enter, we're asked if we're enjoying the course. So let's type yes. And we get the same result that we had before. The comments do not impact the output of our code. Other than serving as reminders for us, we can also use comments to help temporarily ignore some code. Programmers use this technique all of the time. It's called commenting out code. Let's try it. Let's say we didn't want to ask the user how they feel about the course anymore. Instead of just deleting those lines of code, we can comment them out. Let's close the terminal and then come to line number 7, and at the very beginning, we'll put a hash mark and a space. Let's do the same thing for lines 9 through 12. Hash mark and a space. Once again on line number 11, and then finally on line number 12. Let's save our file and check the output. We can right-click and go to Run Python File in Terminal. So we get our greeting, and then it asks us for our name. Let's type Jill. And when we hit Enter, that's it. It doesn't ask us how we feel about the course. That's pretty cool, right? Comments are a powerful tool for programmers, and as you've seen, we can use them to serve as reminders, provide explanations for other developers, and even help us with debugging code. Alright folks, it's time for a challenge. Now that you have an understanding of variables and data types, let's put your newfound powers to use by figuring out what the following lines of code will output. I really want you to try and figure out the output on a sheet of paper. Go line by line just as if you were the Python interpreter, and write down what you think the output will be. This is going to help you think like a computer. If you find yourself really struggling, you can always type the code into your IDE and run it. Either way, make sure you watch the solution video where I'll provide a detailed explanation of why the output is what it is. How'd it go? Ready for the answer? Let's work our way through the code line by line to figure out the output. Starting here on line number 1, it's our familiar print statement. This is just going to print out challenge 1. Moving on to line number 2, it's a blank line, so Python just ignores this completely. Coming down to line number 3, notice that it starts with a hash mark. This means that it's a comment. So whenever Python sees a hash mark, it just ignores the rest of the line. No output here either. Next, on line number 4, we come to our very first variable. It's named message, and the value is the string. This is going to be tricky. Whenever I come to a variable, I write it down and I keep its current value. So let's create a box for message. And its value, this is going to be tricky. Great. Next, on line number 5, we update the message variable with the value, very tricky. Actually, is that what happened here? Did you catch our trick? We created a new variable named capital M message. So let's write that one down. We'll create a new box, and it's capital M message. And its value is very tricky. On to line number 6. We print out the lowercase m message variable. Keep in mind, variables in Python are case sensitive. So this is only going to print out our very first message variable. And then next, we have a hash mark. Once again, this is an inline comment, so Python is just going to ignore this entire section of the code. Hopefully you're starting to get the hang of how Python ignores white space and comments. So let's move to the next one, line number 7. This is also a blank line, nothing to do here. Coming down to line number 8, we have another hash mark. This entire line is a comment, there's no output. Next, on line number 9, we have a new variable, and it's named result. Let's create a box for it as well. Perfect. And if we look at the value of result, it's 2 with 2 stars and a 3. Did you remember that 2 stars next to each other represent an exponential operation in Python? If so, that's awesome. So this is 2 to the 3rd power, or 8. Let's write it down inside of our box. Then, on line number 10, we're going to print out the value of our result variable. But first, we're going to print 2 to the 3rd power equals. Great. Moving on to line number 11. We're changing the value of our result variable just to a simple subtraction, 5 minus 3. So now we can update result with the value of 2. Cool. On to line number 12. Here, we print out the result. Or do we? No, we don't actually. Can you spot why? Yes, it's because of the hash mark. Whenever Python sees this, it's going to treat this entire line just like a comment and completely ignore it. Moving on to line number 13, it's just another blank line, nothing to see here. And then finally, line number 14, we print out challenge complete. Were you able to figure out the output on your own? If so, that's awesome. You're well on your way to mastering the ins and outs of variables and data types. If not, that's okay too. It takes lots of time and practice for most people to really understand how these things work. I'll be including reminders and tips as we go along, and you can always check the exercise files for more practice. But whatever you do, don't give up. Have you ever received a note from someone that read, "Would you like to go out?" And the options were yes, no, or maybe. As humans, maybe is often a valid response to a question. It's not quite yes, but not exactly no. However, computers are different. Things are absolute. There's only yes or no, true or false, 1 or 0. Any expression that breaks down to either true or false is called a conditional or Boolean expression. For example, does the number 4 equal 2 times 2? Yes, that would evaluate to true. But is it greater than 5? No, then it would be false. And finally, here's an example that doesn't involve numbers. Is my name Frank? Nope, it's Anise. This would evaluate to false as well. These are Boolean expressions. But as we've learned, computers don't speak our language. We can't just ask it questions directly the way we have it here. And that's where relational operators come into play. We've already worked with several operators. We've used arithmetic operators like the plus for addition or the percent sign for modulo. We've also used the equal sign for assignments. Relational operators work with two operands, and they return a value, true or false, based on their relation to each, thus the name. The first relational operator we'll look at is the equality operator. It's represented by a double equal sign, and is used to evaluate the equality of the operands. As an example, 4 double equals 2 times 2 would be true. The left side of the operator equals the right side of the operator. Here's another example. We have a variable called name, and we've set it to equal to the string Anise. Then we use the equality operator to compare it to the string Frank. The result will be false because these two strings are not the same. It's a common mistake to use only one equal sign when you mean to test for equality, so be on the lookout for that potential bug if your program isn't doing what you expect. Let's come over to our Python shell and we'll do a rapid-fire round of conditional checks. Let's start out easy. First, we're going to start our shell, and then we'll do 5 double equals 4 and enter. We got back false because, of course, 5 is not the same as 4. But what if we wanted to check the fact that they are not the same? Then we would use the not equal sign. That looks like this: 5 with an exclamation mark, no space, followed by an equal sign, and then we can use the number 4. When we hit enter, we get back true. Indeed, 5 is not the same thing as 4. Let's try another one. Let's check for 5 being greater than 4. For that one, we're going to use the greater than sign that you already know from mathematics. So we'll put our 5 space, the greater than sign, and then the number 4. When we hit enter, of course, that's true. Now, if you forget which way to place the angle bracket, just remember the hungry alligator opens his mouth to the bigger number. Okay, let's look at another example. If we turn the greater than sign the other way, then we're checking for 5 being less than 4. So let's do that now. 5 space, less than sign, and then the number 4. And of course, we get back false because 5 is not less than 4. Are you starting to get the hang of relational operators now? I hope so. Let's do a few more. This time, we're going to create some variables. First, we're going to create a variable named age, and we'll set it equal to 15. Then, we'll create another variable named age to drive, and we'll also set it equal to 15. Now let's do some comparisons with these two variables. First, we'll check if age is equal to, using the double equal sign, age to drive. And when we hit enter, we get back true. Here, the Python interpreter is comparing the values of the two variables. And yes, the value 15 is equal to the value 15. There are a few other relational operators available in Python as well. Here's a listing of them and how they're used. You can compare if two numbers are greater than or equal to, less than or equal to each other, and much more. I've created a worksheet in the exercise files that will help test your skills with Boolean expressions and relational operators. I really encourage you to spend the time going through each item. This will help you to master Boolean expressions. In the real world, we make decisions based on current conditions all of the time. If it's raining, I'll take my umbrella. If I'm sleepy, I'll grab a cup of coffee, and so forth. The most common way for a computer to make decisions is by means of an if statement. We've seen an example of an if statement earlier in this course, but let's dive deeper to understand the ins and outs. An if statement has this general structure. It starts with the word if. That's where it gets its name from. Then it checks some condition. And if that condition is true, then it will do the work that you've placed inside of it. To visualize this, think of it as a flowchart with only one check. If it's true, then the program will proceed to execute the statements. If not, then it just ignores those statements as if they don't exist. Here's a simple if statement in Python. It starts with the word if. Then we have our condition or Boolean expression, 5 less than 6. Next, we have a colon. This is part of the syntax or rules of the Python if statement. And on the next line, we have an indented line of code. This contains a print statement that will run if our condition is true. The indentation in Python is very important because that's how the interpreter knows which statements belong to the if. In fact, we have a name for statements that are grouped together this way in programming. It's called a block. In this example, there's only one statement in our block, but we could easily extend it like this. And now we have 2 statements in our block. In Python, the block is ended as soon as we come to a line that's not indented anymore. This new print statement isn't indented. It's not part of the previous if statements block. Let's move over to VS Code to take a look at an example in the 0402 exercise file. This code should be familiar to you. This is our code that we used before that includes an if statement. Let's go ahead and run it and check out the output. So we'll come down to Run Python File in Terminal. First, it asks, what's your name? Let's go with Frank. And then, are you enjoying the course? We'll choose yes. And we get an output. That's good to hear. And then the final statement. But let's see what happens if we choose something other than yes. We'll close this down and run this code again. Once again, for what's your name, I'll go with Frank. And then, are you enjoying the course? I'm going to type dance. And as our output, we only get the final statement. Did you see what happened? I only got the final statement because the line of code inside the if was ignored. That condition, answer equals yes, evaluated to false. The only thing our if knows how to handle is an answer of yes. And dance certainly doesn't equal yes. Recall what I mentioned earlier about the importance of proper indentation. Let's see what would happen if we failed to properly indent our code for the if statement. We'll change that here on line number 9. So first, let's close this down, come on line number 9 right in front of our print statement, and we're going to delete it. Let's save and run our file again. This time we get an error, an indentation error. That's because Python requires the indentation so that it knows what code belongs to the if. It's standard in Python to use 4 spaces for doing some indenting. If we come back here to our code, we can close this down. We can use the Tab button to add 4 spaces to our code. When we click Tab, the IDE automatically converts this to spaces for us, which is pretty handy. If statements allow a program to take different paths while it's running. So far, we've just gone from top to bottom, processing every single line, only one path. but that's boring and it doesn't give us much opportunity to interact with the user. Now, we know how to switch things up based on some condition, and we can start to write much more interesting programs. With if statements, we've discovered a way to add a bit more flexibility and excitement to our programs. But so far, if the condition is false, then we just don't do anything. But typically, we'll want to take some action in this case as well. This is done with the if-else statement. It looks very similar to our normal if statement, except it has the else keyword along with a colon, followed by a code block. In programming, this is called the else clause because you never find it without an accompanying if statement. Just like in English, if I said, every morning before I go to work, and that's it, that would be an incomplete thought. It's just a clause. I'd have to add something like, every morning before I go to work, I enjoy a cup of coffee. Now the thought is complete. Similarly, we don't use the else clause without an if statement. Let's look at an example. If 5 is greater than 6, then we're going to print 5 is greater than 6. Weird. Otherwise, if it's not true that 5 is greater than 6, then we're going to print 5 is not greater than 6. When this code is run, first the condition of the if statement will be checked. And since 5 is not greater than 6, then it'll evaluate to false. Since the condition is false, it's going to skip over the if's code block and drop down to the else clause. The result will be the output of the else's print statement. 5 is not greater than 6. Let's switch over to VS Code to see a few more examples of the if-else statement. We're here in our 0403 exercise file. Starting on line number 1, we've created a variable named plant, and we've set its value equal to cacti. Then, coming down to line number 3, we have our if statement. Here, our condition checks to see if the value of the variable plant equals cacti. If it does, then we're going to execute what we see here on line number 4. That is, we will print the name of the plant and the fact that it doesn't need a lot of water. But if it's not true that the value of our plant variable equals cacti, then we're going to print the name of the plant and the fact that it loves water, which is what we see here on line number 6. But regardless of what the value of our plant variable is, we're going to print thanks. Let's go ahead and run this to check the output. And there you have it. Cacti don't need a lot of water. Thanks. Is that what you expected? I hope so. Our variable plant was assigned the value of cacti. So when we came to our if statement on line number 3, cacti does equal cacti, and so we printed out cacti don't need a lot of water. Now let's go ahead and change our plant variable to something else. Let's change it to irises, for example. Let's save it and run it again. This time we get irises love water. Thanks. That's because irises does not equal cacti. So we skip over the body of the if statement here on line number 4. And instead, we execute what's inside of the else clause. Irises love water. But the important thing to remember is that regardless of what the plant variable's value is, we always print out thanks. With if-else statements, we will always execute one of the code blocks, depending on the result of the condition test. This makes it perfect for when we need some action to take place in our programs. By now, you're pretty familiar with conditionals in Python. We start with an if, followed by our condition, and we end the condition with a colon. Then, on the next line, we indent the block of code that we want executed. And the else is very similar, except there's no condition to check. In the Java programming language, the if-else statement has a slightly different syntax. Remember, syntax is just the same thing as saying rules for how a programming language expects its code to be written. After the if keyword, there's a set of opening and closing parentheses. Inside these parentheses is where you put the condition you want to be tested. And instead of a colon after the condition, a pair of opening and closing curly braces are used to denote the code block for the if. The same thing is true for the else clause. Now, although it's customary to indent the statements in the code blocks, it's not a requirement the way it is for Python. Let's look at one final example with the Ruby programming language. Ruby is known for its ease of use and flexibility. But just like the other languages, the structure of the if-else statement is the same, but the syntax differs. With Ruby, there are no parentheses or colon to separate the condition. Even the else clause just stands on a line all alone. The one thing that's more noticeably different is the addition of the end keyword. This is how Ruby notes that it's done with this if-else statement, not based on indentation or a curly brace like Python and Java. The cool thing about learning the basics of programming is that once you grasp the structure of the core statements and principles, you can more readily recognize them across all languages. All right, folks, it's time for another challenge. And guess what? We're going to create a guessing game. Using your knowledge of relational operators, Boolean expressions, and the powerful if-else statement, I want you to create a program with the following requirements. First, it asks the user, "What's my favorite food?" If the user enters the name of your favorite food, output, "Yep, so amazing." If the user doesn't enter the name of your favorite food, output, "Yuck, that's not it." Regardless of what the user enters, output, "Thanks for playing." You may find it helpful to plan your program on a sheet of paper first. Think about what functions you'll need to call and what variables you'll need to create. This will make it easier for you when you start to write your code in the IDE. Keep in mind, there's no single one way to do this. Just have fun and try your best. But make sure you watch the solution video where I'll share how I tackled the problem. Welcome back. I hope you had fun thinking of your favorite food and writing the code for this game. I know I did. And here's the solution I came up with. First, starting on line number 1, I've created a guess variable. This is where I'm going to store the result of the user's answer to my question, "What's my favorite food?" Then, coming down to line number 3, I start the if statement. If the user's guess equals cookies, because of course cookies is my favorite food, then I'm going to print out, "Yep, so amazing." But if the user enters something other than cookies, I'll fall down to the else statement, which starts here on line number 5, and I'm going to print what's inside its indented block, which is, "Yuck, that's not it." And finally, regardless of what guess the user enters, I'm going to print, "Thanks for playing." Let's go ahead and run it and check out the output. So we'll right-click and we'll come down to Run Python File in Terminal as usual. So let's see, what's my favorite food? Let's enter cookies. Yep, so amazing. Thanks for playing. And that's it. Did you come up with something similar? Maybe you used a different name for your variable. Or maybe you used the not equals operator instead. That's perfectly fine. In programming, there's almost always more than one way to solve a problem. That's one thing I've always loved about coding. You get to be creative and come up with unique solutions to challenging problems. And now, you're more than halfway through the course. You should be proud of yourself for hanging in there and getting to know the basics of what programming is all about. Functions make programs easier to read, write, and debug. A function is a block of code packaged together with a name. They're a core feature of all programming languages. Yet depending on the language, they may be called subroutines, methods, or some other name. But it's all referring to the same thing, a way to break up your code. In this course, we'll call them functions. In fact, you've already used a few functions like print, to show something on the screen, and input to get a response from the user. There are hundreds of other functions in Python that we've yet to explore. One key benefit of functions is that they help us to avoid writing the same lines of code again and again. You can think of it this way. I love to dance, and if I wanted to teach you my favorite dance move, the shimmy, I'd have to first walk you through all of the steps, one by one. First, you take one step to the right and stomp. Then one step to the left and stomp. Then shake those hips. That's it. Now you know how to do the shimmy. And the next time I say, let's shimmy, you know exactly what to do. I don't have to walk you through the steps each time. It's the same way with functions. We teach the computer how to do something one time, and from then on out, we just call the function by its name and the work gets done. No need to repeat ourselves. Let's imagine this is our shimmy code. It lists out all of the steps of doing the shimmy, one by one. Without functions, we'd have to copy and paste this code again and again each time we wanted to shimmy. So let's go ahead and copy lines 3 through 5. And then we're going to paste it down below. 1 and 2. This makes the code so much harder to read, and we're just repeating ourselves again and again. Let's run the program to check our output. We're going to right-click and go down to Run Python File in Terminal. And we get the shimmy steps. But look, we have a bug. It's supposed to be write and stomp, not stamp. Now we need to go back to each place where we have stamp and fix it. Let's close this down. Can you imagine how difficult this would be if we had a program with hundreds or even thousands of lines of code? It makes me sad just to think about it. Functions save us from having to do this type of tedious, error-prone work as programmers. Let's go ahead and make a change, and we're going to create a function. We're going to call our function shimmy. Don't worry so much about the syntax. I'm going to walk you through how to create a function shortly. Just notice the benefits that we get. So we're going to delete all of this extra copy and paste. Let's fix our typo here on line number 4. And then we're going to call shimmy. Let's do it a few more times. Much easier to read, much cleaner. Let's save our file and then we'll run the code. Perfect! We get all the steps to the shimmy. Pretty cool, right? I'm sure you're eager to learn how to take advantage of functions in your own code. Let's get started. To better understand how functions work, let's create one. We're going to work with an empty file over here in VS Code. Here on line number 1, we're going to create our first function. To do that, we're going to use the define statement. That starts with the DEF keyword, which is short for define. This lets Python know that we're ready to create a function. Next, we need to give our function a unique name. We're going to call this one say_hello. We have to give our function a unique name, just like variables. We could name it anything we want, but we have to make sure we respect the rules of the Python language. For example, I could name this function FunkyTown, but that might confuse me or the next developer who reads my code. So we're going to stick with say hello for now. The next thing we need to do is add an opening and closing parentheses, and then a colon. This is the requirement of Python's syntax for creating a function, similar to what we had for the if-else statement. Once we hit enter, the IDE automatically indents this line of code. Because it's trying to help us out, it knows that functions have to be indented. Now, where have we seen this before? That's right, we do the same thing for our if statements. We often call the code block that belongs to a function its body. So when you hear function body, that's simply another way of referring to the code that the function is going to execute. So let's move back over to our code. In order to get the hang of this syntax, we're only going to have one line inside of our function's body, and it's going to be a print statement that says hello friends. This is the say hello function after all. With that done, we can save our file and let's run it. Uh-oh, we don't get any output. Can you guess why? Think back to when I taught you the steps to my favorite dance move, the shimmy. How could I get you to dance with me? I'd have to call out, let's shimmy, and then you'd know it's your time to shine. Similarly, creating a function means that we taught the computer how to do some work. But in order to have that work done, we need to call the function first. In Python, you call a function by using its name, followed by a set of open and closed parentheses. Let's do that now. Right underneath where we have line number 2, we're going to hit enter, and by default, the IDE tries to help us out and it automatically indents this line of code. But that's not what we want. We're done with this function. So we'll hit enter one more time and delete this indentation so that it's clear say hello is complete. And finally, in order to call the function, we're going to type its name, say_hello, and an open and close parentheses. Let's save it and run our file again. This time we get the hello friends message. Pretty cool. In fact, what if we wanted to say hello a few more times? We can copy line number 4 and paste it right underneath on line 5 and line number 6. We'll save and we'll run it one final time. And there we go. Hello friends, hello friends, hello friends. Now you know how to define and call your very own functions. While this may seem basic, soon you'll learn how powerful it is to incorporate functions in your own programs. Growing up, my siblings and I loved to go to the car wash. And depending on how much money my parents were willing to pay, we could have a different experience each time. For $6, we would get the most basic wash, white foam, one rinse, and a drip dry. But if they were willing to spend $12, then we could get tricolor foam, 2 rinses, and a large blow dryer. It was quite the adventure for 3 small kids. Just like the car wash, in programming, we often want to provide different outputs to our users based on some input. Functions allow us to do this. In fact, let's go over to VS Code to see a function that simulates our car wash experience. We're here in 0503 begin. We have this function defined on line number 1, wash_car, and then we have our open and close parentheses as well as our colon. Inside, we have our car wash steps. First, we have the steps for the platinum car wash on lines 2 through 4. Then down on lines 6 through 8, we have the steps for the basic car wash. Let's go ahead and call this function using its name. We'll do that down here on line number 10, wash_car, and then a set of open and close parentheses. Let's save this file and then run it. So we'll just right click and go down to Run Python File in Terminal. And you probably guessed it. You get both the platinum and the basic wash steps. But what if we only want to do the platinum wash steps when the amount paid is $12 and the basic steps only if the amount paid is $6? How do you think we can do that? I hope the first thing that came to your mind is an if statement. Let's pretend we have the amount paid stored in a variable named amount_paid. Let's see how we can use it inside of our function. So let's close this down and then we'll come back inside of our function and we'll start right on line number 2. We'll add our if statement. So if the amount paid is equal to 12, this is for the platinum wash, then we want to do the platinum wash steps. Remember, we have to indent the statements. This is how Python knows that all 3 of these print statements belong to this if. Next, we'll come down to line number 7 and we'll create another if statement. This time it's for the basic car wash. If the amount paid is equal to 6, then we're going to do the steps in the basic car wash. Once again, make sure you indent the statements that you want to include inside your if. So now, let's save it and run our file again. And look, we get an error. Python is letting us know that the amount paid variable is not defined. So we need to do something to bring this variable inside of our functions world. In order to do that, let's close down this window and we're going to come up to where we've defined our function. Inside of our open and close parentheses, then we're going to include amount paid. This is how we let our function know about the amount paid variable. Let's save our code now. In programming, this variable has a special name, a parameter. Parameters allow functions to change their behavior based on some input. Let's go ahead and run our code again. But look, we get an error. Wash_car is missing one required positional argument? But what does that mean? What is a positional argument? Well, similar to how we have parameters as the name for the variables we use in our function definition, we have arguments as the name we use for the values that we give to our functions. And we give our functions arguments by placing a value between the open and closed parentheses in the function call. Let's do that now. We're going to close down this pane, and then here on line number 12, where we call our function, let's give it the number 6 in between the open and closed parentheses. This is going to serve as our argument. After we save our file and run it, let's notice the output. And indeed, we get all the steps for the basic car wash. On your own, provide 12 as the argument to the function and enjoy the platinum wash experience. One thing to note is that sometimes parameters and arguments are used interchangeably. You'll have to rely on the context to figure out the meaning, but don't despair. The key thing to know is that functions have the ability to change their behavior based on their parameters and arguments. Growing up, your mom may have asked you to go get the mail. So you leave, get the mail, and then you bring it back to her. Other times, she may have asked you to wash the dishes. So you go and wash the dishes. There's nothing to bring back. That's kind of like the functions we've been creating so far. They do some work, and then that's it. But when you need something back, just like how your mom expected the mail, you can use functions that return a value. Let's move over to VS Code to see it in action. Here on line number 1, we've created a function, and it's called withdraw money. It takes in 2 parameters. The first one is current balance. This stores the current amount of money that you have in your account. The second parameter is named amount. This is the amount that you want to withdraw. Then on line number 2, we have an if statement. The if statement checks to make sure you have enough money in your account to cover the amount that you want withdrawn. If you do, then we come to line number 3, where we update the current balance with some simple subtraction. We take the current balance and we subtract the amount. And then finally, on line number 4, we print out what the current balance is using this variation of the print function. Here on line number 6, we make our call to the withdraw money function. We pass in 100 for the current balance and 80 for the amount. Let's run the function to check the output. And as you expected, the balance is 20. Now, let's say after we withdraw the money, we want to check the new balance later in our program to see if we need to make a deposit. This is where returning a value from our function comes in handy. In Python, when creating a function using the def statement, you can specify what the return value should be with a return statement. A return statement consists of the return keyword and the value that the function should return. Remember, Python has over 30 keywords that it uses to take special actions. Return is one of those keywords. We need to make a few changes in order to take advantage of the return keyword. The first thing we're going to do is on line number 3, we'll hit enter, and then we're going to return the current balance. We're going to use the return keyword in order to do that. So we'll just type return and then current underscore balance. The next change we need to make is to copy this print statement and remove it outside of our function. Since we're going to use it later, let's not completely delete it. We'll just cut and remove that extra line. Okay, great. We're almost done. Coming down to line number 6. Since we want to use the value for later, we need to store it inside of a variable. To do that, we'll go to the beginning of the line and we're going to create a variable that we call balance. And we'll use the equal sign in order to assign it the value from our function. The final thing we want to do is to add an if-else to check and see if we need to make a deposit. So underneath this function call, let's create our if statement. We're going to check if the balance is less than 50. Then we're going to say we need to make a deposit. Else, we're going to print out nothing to see here. And that's it. Let's save our file and then run this code. Perfect. We get a message we need to make a deposit. That's because our balance variable now has the value of 20, so we fall inside of our if statement and it's letting us know that we need to make a deposit. Being able to return values from functions is a cornerstone of programming. I can't wait to see what you're able to build with this new power. We've seen functions that fall into 4 main categories. Those that have no parameters and no return value, no parameters but do return a value, those that have parameters and don't return a value, and finally, those that have both parameters and a return value. But so far, we've only seen these functions in Python. Let's take a look at how a few other languages handle functions. First up is Java. This is the no parameters and no return value example of a function. Does it feel slightly familiar? Yes, the curly braces are used to mark off the function's body, just like how we saw curly braces used for the code block of an if statement. Also, we have the function name followed by empty parentheses, just like we do in Python. But what's totally different here? It's the void keyword in front of our function name. Can you guess what that void means? It means that our function doesn't return a value. Similar to how we can't get any money back from a voided check. It has no value. Unlike Python, Java requires that you always specify explicitly what the return type is of a function, even when that function isn't going to return a value. Okay, on to the next example, Kotlin. This is the has parameters and no return value example of a function. Let's look for similarities and differences from what we've seen so far. Just like Java, we use curly braces to mark off the function's body. And similar to Python, we have a keyword, fun, which is used to signal that we're creating a function. However, unlike Python, we have to specify what the type of our parameter is when we define the function. We do that by placing a colon after the parameter's name and then the type. In this case, it's a string. As you explore new programming languages, I encourage you to compare languages as it makes it easier to learn. Do you feel like you can spot a function now? Let's put your skills to the test in a rapid-fire round of Find That Function. Where's the function here? Yep, you got it. This is the Ruby programming language, and this is how functions are defined. Okay, On to the next one. Can you spot the function? Yes, that's right. This is the C++ programming language, and this is the syntax it uses for functions. One more. Can you find the function? Nice work. This is some JavaScript code, and indeed, this is how you define functions in JavaScript. Okay, thanks for playing along. Even if you didn't understand exactly how each function worked, you were able to spot them easily in code. That's half the battle. You're now an expert function spotter. What's your favorite city? Mine is Santa Barbara, California. I love the food and the amazing landscapes. As you drive through the city, you can see both the mountains and the ocean at the same time. I just love it. So, for our final challenge, I'd like you to create a program that prints out the name of your favorite cities. But here's the catch. You need to use at least one function. Your program should meet the following requirements. Has a function named favorite_city. Favorite city should have one parameter, name. You should call favorite city at least 3 times. The output should include, one of my favorite cities is. Remember to have fun and try your best. In the solution video, I'll share how I tackled the problem. Welcome back! I hope you had fun thinking of your favorite cities and writing the code for this challenge. Here's the solution I came up with. On line number 1, I just have a comment. It prints out the name of a favorite city, because that's what our function does. Then, on line number 2, we have the function definition. Notice that we're using the def keyword. This is how we let Python know that we're creating a function. It takes in one parameter, named name. Then, inside of our function on line number 3, we use the variation of the print method that first displays a string, one of my favorite cities is, and then it prints out the value of the name variable with a space before it. On line number 5, I call the favorite city function with one of my favorite cities, Santa Barbara, California. Then on line number 6, I call it again with another one of my favorite cities, Asheville, North Carolina. And finally, on line number 7, we call our function using Amsterdam, the Netherlands. Let's run this code and check out the output. Yay, it called the function 3 different times with each of my favorite cities. Cool! Were you able to use a function to print out your favorite cities? How'd it go? Did you come up with something similar? I hope so. Breaking up our code into reusable chunks helps us to develop programs that are easier to read, write, and debug. Now you have one more tool in your programmer's belt. There are hundreds of programming languages out there. Let's take a look at the most popular. At the time of this recording, Java is number 1, closely followed by C, C++, and our friend Python. And you might be surprised to know that they're all related. That's right. Java, Python, and C++ all inherit ideas from C. The C programming language was developed in the 1970s. It's used for programming operating systems, games, smart devices, and even compilers for other languages. Here's an example of a program in C. Let's walk through it. The include statement we see here on line number 1 is very common in C and C-based languages. It's the way you, as a programmer, get to link to code that someone else wrote into your program. Did you know you could do that? This is very important to know because as programmers, it's our job to develop software that meets a business need. And we often do this with a specific deadline in view. So it wouldn't make much sense to write the same types of functions again and again, especially if they're already available and have been verified by other programmers. In fact, this is so common in computer programming that we call the grouping of variables and functions that someone else has written and verified a library. In our example, we want to link to the standard input and output library. This is available for the C language. This library includes the code for the printf function. We use printf to display our hello world message to the user. Okay, enough about libraries. Let's go to the next line of code. The 2 forward slashes are how we create a comment in C, whereas if you recall in Python, we use a hash mark. There's a function here called main. This is a very important function in C-based languages because it's the function where the program begins. And just like what we've seen with Java and JavaScript, curly braces are used for the function's body. Both languages adopted that syntax from the C language. And finally, as our function's body, we make a call to the printf function to display our message. And that's it for our C program. If you're interested in making a desktop, web, or mobile application, C is not really your best choice. It's a low-level language and requires more advanced programming knowledge. However, some of its successors are ideal for these types of applications. Let's take a look at a few. First up, Java. Java is a cross-platform programming language. This means that you can write your Java code, compile it, and then any device that has the needed program installed can run it. It's famous for desktop applications and mobile apps for Android. It's a C-based language, but unlike C, everything in Java is in what's called a class. Here's some Java code. It looks pretty close to what we saw with the C programming language, with its use of curly braces, semicolons, and the main function. One of the new additions is the class keyword. This is how the Java language prefers to organize its code. Now let's take a look at one more language, C++. C++, as the name hints at, is also a C-based language. It's easier to learn and work with than C because it has something called garbage collection. Garbage collection cleans up unused variables for us so that we don't have to worry about handling it ourselves. C++ is used for games and game engines. In this video, we've only covered 3 programming languages, and there are dozens more. Swift and Objective-C for iOS development, Ruby and JavaScript for web apps, and so on. With so many languages available, you're probably wondering, which one should you choose? Well, you already have the basics of the Python language under your belt, so it makes sense to continue with that. I recommend the course Python Essential Training to help further your knowledge of the language. However, depending on what you want to develop, now you know what other languages you can pursue. We're done! Congratulations! You now know the fundamentals of programming. You've learned how programs are created using programming languages. You've been able to write source code and run it from your own computer. And you have a foundational understanding of the Python programming language. I hope you feel inspired to keep learning more. At this point, the best thing you can do is start practicing. Don't feel that you have to learn everything there is about a specific language or tool before you can get your hands dirty. I could watch every video there is about salsa dancing, but I won't get any better until I get up and start moving. It's the same for you in learning how to program. You need to practice coding on a consistent basis to get better and to feel more confident. Here are a few ideas to help you get started. Search online for a local meetup group that caters to new programmers. Participate in an online community focused on your chosen language. Create some programs that use the skills you've learned so far. Check out the exercise files for a few ideas. Also, be sure to check out the other courses in the Programming Foundations series. This will give you a well-rounded view of what's involved in developing software. I really enjoyed putting this course together for you, and I wish you much success on your coding journey.
If you are looking for teaching stuff, education stuff, programming series, application, and Android development, coding skills, marketing skills, presentation skill. Paid courses for free are available. Thank you for calling Eduvvo.